elastic collisions. So here's the setup. We have two balls with equal mass. So this is before and this is after. Maybe I should write before and after. Yeah. So this is before and this is after. Okay. So if these two balls collide, did you notice if you ever played billiard, they always split in 90 degrees? Unless you put some English on it, spin on this ball. Yeah. So typically they tell you these things. So usually this is 60 and 30, something like that. You know what I'm saying? We'll just call it theta and phi. Okay. Then you have to find V1 and V2 is the question. You get it? So they tell you, usually they just tell you both of them. Or they tell you this is elastic collision and just one of them. If this is 60, then you have to calculate the other is 30. Turns out. Now you might ask, why is it always 90 degree split if it's elastic collision? Well, I'll prove that to you after this problem. But on the question, they usually don't put a proof. They just put it like this and find V1 and V2, right? Final. We are not going to put initial final because this is V0 and yeah. Okay, so let's do it. So in x direction, your momentum is conserved, right? So we'll first consider momentum in x direction. Okay, so originally you have m v naught, correct? And the other side, we can make triangles out of this, right? So do you see that this is equal to v1 cosine theta plus v2 cosine phi? I forgot m's. Hold on. Here's m. Here's m. But m's cancel, right? So cancel m, and then so we have v naught is equal to v1 cosine theta plus v2 cosine phi is the equation we get. I'm going to call this equation 1 for now. Okay? Now, then we shall consider momentum in y direction. Copy and thank God for computers, right? You guys cannot do it. You have to write it down. So change that to y direction. Okay, in y direction, this is a sine component, this way and this way, right? So you have 0, because originally there is no movement in y direction, so that momentum is 0. And the other side, we have m v1 sine theta. And then you have to put the other one as a negative. You know what I'm saying? Okay, well, it depends on, is theta negative angle? No, it's given as like 30 degrees, for example. So it has to be negative, downward, right? Opposite direction. So far, so good. Dividing by m, see, it only works if the masses are equal, right? We are looking at billiard balls, which are identical. So you have v1 sine theta minus v2 sine theta, sine phi. Good. I'm going to call this equation 2. Now it's systems of equation between 1 and 2, isn't it? Oh, should we use substitution technique? Okay, which one do you want to eliminate, V1 or V2? Your choice. They're the same thing, so just quickly make up your mind. V2, V1, V2, V2. V2 is equal to V1 sine theta over sine phi. Good. And then I'm going to substitute this, number 1, equation number 1. Good? So let's see what that gives us. So we have V naught here is equal to V1 cosine theta plus V2 is this thingy. So we have V1 sine theta over sine phi times cosine phi. Good. So what we have is V naught is equal to V1 cosine theta plus V1, is it sine theta cotangent phi? Do you want to do this way or find the common denominator? Clock's ticking, make up your mind. I can do it either way. They give you the same answer. Just this way? Okay, sure. Common factors, so V1, and then we have cosine theta plus sine theta and cotangent phi. Good? Now, remember we are solving for V1 and V2. Good? So therefore, your V1 is equal to V naught over cosine theta plus sine theta and cotangent phi. Okay? Now, the difference is, do you want to just use, no, you don't want to use this. There's a much prettier expression by, this is cosine over sine, right? So we multiply sine phi to the numerator and denominator. Had we done the common denominator here, then we don't have to do it here. But let's say it's the same thing. You know what I'm saying? So let's see what this gives us. So this is equal to V naught sine phi over this thingy is cosine theta sine phi plus sine theta and multiply. So this is sine phi cancels, right? So cosine phi. Tell me this is not too much identity. Why does the denominator look so familiar? Cosine sine plus sine cosine. This is also known as, somebody say it. Oh, sine theta plus phi. See, this is pretty. That's V1. Okay? Shall we find V2? V2, remember, is this thingy, right? Up there. So V2, I'm going to zoom out a little bit so I can see it. V2 is equal to V1 sine theta over sine phi from up there. Okay, now I can zoom in and substitute this thing in. So V1 is this thingy, right? So we have V1 sine theta over, what did I do? V1, hold on. V naught, V naught, and then sine phi over sine theta plus phi times sine theta over sine phi. You get it? Because that whole thing is just that much, so I have to multiply by that. And then do you see the sine phi cancels? So what we get, V2 happens to be V naught sine phi over sine theta plus phi. Very symmetric looking, beautiful equations. You know what I'm saying? Say yes. Okay, then, so this is typically how the problem is. And also sometimes problem does not give you both angles, but sometimes they give you this entire vector, magnitude and the direction, and then you have to find the other vector. It's still systems of equation between 1 and 2 now, isn't it? So that's simple, okay? Now, the proof, why do they always split up in 90-degree angles, okay? In order to do that, I'm gonna recycle my work here, copy that much. Here, and then get rid of this much. Because this much, we have done it before, right? Okay, so the question is, why 90-degree, right? In elastic collisions, right? Okay. In elastic collision, it conserves the momentum. Momentum is always conserved. What else does it conserve? Huh? Energy is conserved, right? So we do energy. Energy. That's not how you spell energy. Energy conservation tells you that 1/2 mv0 squared is equal to 1/2 mv1 squared plus 1/2 mv2 squared. Eh? Energy, remember, is a scalar, so we just add total kinetic energies, and this needs to be conserved. Divide both sides by m and multiply 2. So you have v0 squared is equal to v1 squared plus v2 squared. I'm going to call this equation 3. So it becomes a systems of equation between 1 and 2. Okay? Since you see square here, I think we should square these things up, right? So let's do that. So 1 squared, I want to go to green now. Equation 1 squared. So you have v0 squared is equal to v1 squared cosine squared theta plus 2 v1 v2 cosine theta cosine phi plus v2 squared cosine squared phi. 8. Now, squaring equation 2, you get 0 squared is equal to v1 squared sine squared theta minus 2 v1 v2 sine theta sine phi plus v2 squared sine squared phi. You with me? Guess what I'm going to do next? I'm going to, you guys can go. I just continue this video. I'm going to add vertically. If you add, this thing gives you v0 squared. Do you see this thing is just v1 squared, cosine squared plus sine squared? And here is a common factor of 2 v1, v2. Then you have cosine theta, cosine phi, minus sine theta and sine phi. Good? And then plus v2 squared. So far so good? Somebody tell me what this thing inside the parentheses is. That is sine theta minus say theta. That's cosine theta plus phi, isn't it? Plus v2 squared. Okay, so this is v0 squared. Now I'm gonna write equation 3 down here. This is equation 3. Then guess what I'm going to do now? I'm going to subtract vertically. Okay, so if I subtract vertically, then this side becomes 0. This cancels, that cancels, so you have 2 v1, v2 cosine theta plus phi. So far with me? Since v1 and v2 are not zeros, this must be 0, right? So that tells you cosine theta plus b is equal to 0, meaning theta plus b is equal to pi over 2. Bang! Proof. In elastic collision, they have to split in 90-degree angle. Unless it's approaching speed of light, then it actually angles not even close. It's like I've seen 45-degree angles or smaller. Right? You can still conserve kinetic energy without preserving this. Okay? Little bit of key insight that somebody in third period found out. Remember, this was V naught, right? And then V2 was like this. And this was V1, and then this was V2, something like that, right? If you say V naught square is equal to V1 square plus V2 square, that means this is a Pythagorean theorem. So this, I'm going to put this here, and then V2. When you're in a hurry, this happens, right? This is right there, and then this happens to be V naught. Right? This square is equal to this square plus that square. That means this has to be 90 degrees, eh? See, geometry is superior than algebra. How about that? Let's call it a day.